So we have started all the way from looking at the scope of C++. We did a bit of talking about where the language has come from, where the language fits in as far as the computer system is concerned, the role of high-level programming language all the way down to low-level, the fact that computers understand ones and zeros, and eventually that took us to C++. And then we have looked at the fact that the input and output stream allow us access to, give it some time, right? Has it come out? Give it some time. The ions need to reset themselves. Right. So all the way to, but bring my charger in case I forget. Give it some time. Yeah. I can later explain to you what's happening. Right. So all the way to well, the fact that we need to include some preprocessor directives for our code to work. So we make use of the IO stream most of the time, or almost all the time. And then we have the driver function, which is the main function that we have been using. The main function returns an integer. So normally, if it returns a 0, then it means that the code has successfully been executed, because we normally put the return 0 at the end of the code. And then we have the beginning brace and then the closing brace setting the scope of the int main function. The int main does take arguments though, so it can take some parameters. So if you look at some of the examples from last week, some of the examples included cases where you pass files as an input to the main function, and then you make use of it. If you haven't done so, just revisit last week's materials to look at how things work. And then we introduce other functions where we said we can write our own functions. If you want to use your function, you can declare it. And then of course you can define it before the main functions as well. Or you can just declare it and then you put the definition after the main functions. There is another approach called inline function, where you put the actual function definition inside the main function. So the only problem with that is that when it reaches that point, the whole code will be loaded. So normally it's not necessarily efficient, so people don't go with that approach. Yeah. Then we talked about so many different types of data types, which allow us to create our variables. And these data types both have different memory space they occupy. Yep. Eventually that took us to creating our own data types, the structures. Yeah. And with the structures, we eventually talked about templates, because templates allow us to get rid of the struct keyword, right? Then some things about memory management, like pointers, giving us access a way to store the address of a variable. And then we talked about referencing as well, which is basically a direct alias. And the difference between pointers being pointers, you can reassign them to a new variable or the address of another variable, whilst reference, basically you need to stick with it. Yeah, referencing is like being born into a family, right? It's just connected by blood. You necessarily can't change it. Whilst the pointers is like brother from another mother. Let's say you can change them, but you know what I mean. And I think that sort of wraps things up. I mean, things like passing pointers to functions and passing references to functions or passing values to functions. The key difference between the three is that the passing by value simply means that after the function escapes, the value that the modification you made to that particular value does not have a direct effect on the variable itself. Yeah, if you want to have a direct effect on the variable, then basically you need to address it differently. Alternatively, we use references or pointers to affect the value stored in that particular address. Sort of a wrap up of everything with that. Yeah. Now we want to talk about something that gives C++ its object-oriented features, right? And before we jump too far into it, I want to ask the question: are we familiar with what a blueprint is?
Yes.
a map of how to build something. So if, let's say, an architect's blueprint of how the building should be made. Does anybody have a 3D printer? Has anybody done some 3D printing before?
No.
You do the model, and you can print the design again and again. I should have brought some stuff. But basically, if you look at the blueprint, or let's say if you have a model of how something should be built, or let's say, I think I prefer 3D printing example because I think it's the sort of the easiest, because you've made a software model of, let's say, how a cap is. You plug it into the software, and the printer will start printing it out for you. As long as the model remains the same, you can print so many different versions of it. So the same way, if, let's say, we have a blueprint, if we have a blueprint of a car, what are some of the common features of a car? I don't know, we can say cars have what they are making money, right? So we basically have a car. Let me try. Hello, how you doing? Let me try to draw the flashiest car I can ever draw. No, that's not true. That's the flashiest car I can ever draw. I'm very glad those online cannot see that. Sorry? Transmission. So the transmission, and what else? Number of doors?
Nitro.
Nitro. Nitro. Fuel type, you mean? Diesel or petrol or electric?
Yeah, I was actually joking when I said nitro.
I don't know. I just believe whatever you say. As you can tell, I'm not a car expert here, but then if, let's say, we pick, so we have this blueprint that we've sort of made up, right? So we have make, model, year, transmission, whether, I don't know, fuel type, all those kind of things, yeah? Number of doors and everything. So we've sort of created a blueprint. If we say we want to buy a car, right? I take all your money and I want to buy a car with it. No, we want to buy a car together. We put our money together, want to go and buy a car. When we start considering what car we want to buy, some questions will come up. What kind of make are we going for? I don't know. Most of the people say, oh, Japanese car, or I don't know, German car. Then maybe that would take us to Benz and all those kind of things. They say, okay, we have that consideration. Do we want 5 doors or anything? Do we want electric car? So we've started by plugging in the specifics as far as the specific features that this particular blueprint, the blueprint gives us the base or a template. We plug in the features, and that will define the particular cars that we want. If, let's say, Raj wants his Ferrari, then straight away, it's still a type of car, but he's going to plug in some specifics. Then you think about the year and everything. The blueprint has not changed, but the individual objects of that blueprint is slightly different. Does that make sense? So our data type that we just created, our blueprint that we just created is what? Of type car. But this particular type, we've created 2 objects, one being the Benz and the other being the Ferrari. The number of doors or the transmission for the Benz will be different from the Ferrari, but they both share the transmission. So if you want to go a step deeper into it, at the point where we're thinking of our blueprint, we can call the blueprint class now, right? It's just a type of data type. It's just a data type. So we have our class that we call car. We have given it several variables. The transmission, it can be a string, whether it's electric or whether it's whether it's petrol or diesel. The year will be maybe an integer, 2002, 2001. I don't know, maybe we buy far in advance, 2028 or something like that. Yeah. So as we think of the specific features, then basically we have some variables that we'll be filling in for the different types. Let's say the car has certain functions. Let's say all cars have certain functions that need to be executed. For example, what would you call it? Let's say we buy cars on lease. Okay, so in that particular case, we may have a variable called cost of the car. So if bought on lease, then the lease function would take the year and all those kind of things at the time it was bought, and then maybe customer details, and then we'll set how much I have to pay monthly. Still a function, but also part of our blueprint that we are giving out.
Yeah.
Does it make sense so far, but for both people online and in class?
Yes.
Good. Destin, no, no, that's Oyinda. No, wait, I'll remember. I'll come back. I don't want to. I want to say the Oluwaferami. I want to say the name properly. Have you been working on that? We still got that. How do we create our data type? How do we create classes? How do we create these blueprints? And then how we can create objects of these blueprints, which is like Ferrari and then the Benz of our car blueprint. Yeah. As far as how we say banana in this particular case is concerned, the blueprint is called class. Yeah. And then the Ferrari of type car is basically the object of the class that will be created. The rest is the syntax. Now we understand that this class can have variables and it can have functions. If you are from a different programming language, it will just be something like method in Java or Python. Yeah. Okay. So there are some things in terms of protected and all those kind of things. We're not going to bother about that. We'll just bother about them as we go a bit for a bit more details.